Here the question is the field intensity due to the 2-point charges. Okay, in that question they given that two charges, one is 1 microcoulomb and another one is a 1 microcoulomb. These two placed at A and B. Both the charges are placed at A and B. The distance between these two 2 meters they given. Now they are asking the question the field intensity at the point P, which is at 1 meter away from the point B. Now to find out this field intensity is due to the two charges, multiple charges, we are using the principle of superposition. According to principle of superposition, the total field intensity at point P is equal to vector sum of individual field intensities. Means field intensity due to the A plus field intensity due to the B, we have to add vectorially at the point P. Now so let me find that field intensity due to that A charge. The field intensity due to the A charge is away from the A. Why? Because at A we placed 1 microcoulomb positive charge. This positive charge, due to this positive charge, the field intensity is away from the positive charge. The same way, the field intensity due to the B is equal to B is I'm considering as the B, EB, and it is also away from the positive charge. Why? This is a 1 microcoulomb is positive charge. Now the total field intensity individually EA magnitude is we can find out with the help of a KQ by R square formula. K is what's here 9 into 10 power 9 and Q is 1 microcoulomb, that is 10 power minus 6 coulombs divided by distance between A and P is 2 plus 1 3 meters, so that's why 3 square, that is 3 square and 9 gets cancelled and the remaining is 10 power 3 Newton per coulomb. And similarly EB is equal to the formula we are using as a KQ by R square. KQ by R square, this K value is 9 into 10 power 9 and Q is 10 power minus 6. The distance alone, that is what sir, V2P distance is 1 meter, so 1 square, that is 9 into 10 power 3 Newton per coulomb. Now the total field intensity is equal to, see here, the both field intensities are acting in the same direction, so that's why the total field intensity is equal to EA plus EB. That is EA is 10 power 3 Newton per coulomb and EB is 9 into 10 power 3 Newton per coulomb. So final answer we'll get here as 10 into 10 power 3 Newton per coulomb. This is the final answer. And the direction of E is see here, EA is right hand side direction, EB is also right hand side direction, so that is why both the fields are acting in the same direction, so resultant field also be from A to B. This is the direction, that is away from the B. Now the resultant field intensity direction is, we can draw like this. This is the field intensity due to both the charges. For example, if in this problem both the charges are positive and field intensity is equal to, we found like this. If one of the charge is positive and another charge is negative, means let me draw that one. For example, at point A 1 microcoulomb positive charge is there, at B 1 microcoulomb negative charge is there. Now the distance between these two, for example, I am considering as the 2 meters at the same point P, okay, which is at a 1 meter distance away from the B. here I to find out the total field intensity at 1 meter distance, right? To find out the total field intensity, here's the same principle of superposition. Individual field intensities we have to find out. See here, 1 microcoulomb placed at A is positive, so due to that charge at A, its field is away from the A, and minus 1 microcoulomb is negative charge, so that's why the field acts what's that, towards the negative charge, that is EB is left side direction. And EA value is just before we found, what is that, the same way we can find what is that, KQ by R square, that is equal to 9 into 10 power 9. Q is 10 power minus 6. R is the distance between A and B is 3 meters, so 3 square, we'll get the answer as 10 power 3 Newton per coulomb for EA. And for EB, that is also same formula we are using, KQ by R square, that is 9 into 10 power 9 into 10 power minus 6, and the distance between these two is 1 meter, so 1 square, so 9 into 10 power 3 Newton per coulomb. Here the field intensity, total field intensity is equal to, here EA is away from this right side direction and EB is the left side direction. I am taking the right side direction as a positive and left side direction as a negative. The sign convention I am using, like right side direction is positive, left side direction is negative, so that's why we can find the total field intensity is equal to EA minus EB. Okay, EA minus EB. That EA value is 10 power 3 minus EB value is 9 into 10 power 3, so the magnitude of field intensity is equal to minus 8 into 10 power 3 Newton per coulomb. Here 8 into 10 power 3 Newton per coulomb is the field intensity, and this minus is indicating that the direction of resultant field intensity is opposite to our selected direction. Our selected direction, we consider that EA direction as a positive, EB direction as a negative. We got that negative direction, negative sign for the final field intensity, means our resultant field intensity be in a negative direction. This is the field direction finally, right?